The broadcast is now starting. All attendees are in listen-only mode.
Good morning. This is Sarah Grant, Marketing Manager at Nscaled. Thank you so much for attending our webinar, How to Protect Exchange 2010 in the Cloud. Mike Hamilton and Dave Stubblefield are going to be your presenters today. And first up is Mike Hamilton.
Hi everyone, thanks for attending the webinar today. Today we're going to be going over how to protect an Exchange 2010 system to the cloud. We'll be talking about the recent discoveries that we've made in terms of a great way to do that and accomplish that goal, and using Microsoft's technologies, and we're really proud to present it today. So the agenda for today, we'll be covering what is a database availability group, how to use database availability group in a hybrid cloud for disaster recovery, exactly how the failover and failback process works if you're using a DAG in the cloud, and how to scale it up. So what do you do if you're a big organization and you want to protect a multi-site Exchange environment? So DAG is a really new component in Microsoft Exchange. It's a very nice way to handle high availability across multiple layers. It's actually a core component of the software now. You can have a group of up to 16 mailbox servers that host a set of databases, and it provides automatic recovery from failures. It's basically a boundary for mailbox database replication. So you can think of a database availability group as a group of servers that are called members that replicate a database, which is a group of mailboxes across multiple servers, and those servers can actually be in different locations. It's a very clever way to handle high availability, and it's the most elegant way that I've seen thus far for Microsoft to handle high availability and really disaster recovery and resilience. The architecture provides protection at the database level. So in case you have a database fail, it protects it at the server level, and you can also protect it at the site level. So it really covers every base of the Exchange solution. Any server in a database availability group can host a copy of a mailbox database from any other server in the same database availability group. So this gives you the ability to spread your mailboxes across the database availability group for that kind of resiliency. Let's see if I can go to the next slide here. So in a basic DAG architecture, you might just have a single site, for example, with 2 DAG members. And what this would give you is what Exchange clustering in the past would normally give you, which is resilience within the same site. So in other words, once one server dies and you need to bring up all of your mailboxes on the other server, that capability is still here, but what's neat about it is that it's all worked into the same overall overarching capability of the software that allows you to do the same thing across sites. The beautiful thing about having a cloud provider in this model is that it allows you to get another server off-site. So if you're just protecting a site within itself and you're saying we've got these 2 servers and we want to make sure that they never go down and that people always have access to their mailboxes, then you can have a local DAG. But it used to be that the model for getting your data off-site was it was a lot more complicated, and the failover was a lot more complicated. You might have a continuous replication target in the cloud, or you might have a standby replication target in the cloud. It was not exactly clear. It wasn't seamless, and it certainly wasn't using the same technology. In this case, it's much more of like the same technology that you're using to protect you locally, you're using to protect you in a remote site. It simplifies replication basically by just making it a matter of servers in the DAG having copies of everybody else's mailboxes, and you just think of a DAG as a sort of a replication group essentially. It's totally agentless. There's no additional agents. We're not doing block level protection with this kind of a solution. It's just Microsoft Exchange. And I think one of the things that makes that neat also is that it keeps the skill set for disaster recovery within your Exchange admin, or if you're using a trusted partner for Exchange administration, it keeps that administration of disaster recovery in their skill set. They already know how to do everything, and so it's really just a matter of giving you, the hybrid cloud environment gives you a safe and an additional location to put your data. The recovery point objective is typically less than 5 minutes. Now, if you do some research on what is the recovery point objective for Exchange 2010 DAG, you get a variety of answers. And just to back up a little bit, a recovery point objective is the term that refers to how much data could you lose in the event of an outage? So for example, if you had a mail message come in at 2 o'clock and the server failed and you took a snapshot at 1:30 basically, and then you had a server fail at 2:05, for example, you would lose the mail that you got at 2 o'clock, and you'd lose an email that you got between 1:30 and 2:05. So the recovery point objective says, like, how much of that time am I willing to lose in a disaster recovery scenario? And with Exchange 2010, that number is actually very flexible. So what's happening is it's really doing continuous replication. As of Service Pack 1, Exchange 2010 is doing continuous replication across the DAG members. And so how low your RPO is, essentially the answer would be, what's my RPO? It's as low as possible is the answer. But the way that you would architect the lowest RPO possible is to make sure you've got plenty of bandwidth in between your DAG members, and that your DAG members are sized appropriately so that they're not too busy and they're able to keep up with the load. And then what about the recovery time objective, the RTO? So the recovery time objective refers to how long is my target for bringing the remote site back up in a failure. So, my DR site, how long is it going to take to get that server up and running and be completely ready to service everything that I expect it to service in a disaster? And we've run through several drills with this solution, and we've come up with a number that it's about 20 minutes for a fairly simple architecture. And so this drawing shows you a basic architecture. So on the left-hand side of the slide, we have the customer data center. And the customer data center has a CAS server and a hub transport server and an AD server. It's just sort of the given parts of your local Microsoft infrastructure, basically, in your Exchange infrastructure, as well as a couple of mailbox servers. So this particular database availability group consists of 3 member servers. And you can see that in the drawing as being labeled with MBX, MBX, and MBX on all 3 sides of this and all 3 of the servers. And I've used that blue rectangle to indicate that they're a member of the same database availability group. You can also see that database 1 is the active database on the leftmost mailbox server. Database 2 is the active database on the customer data center, the one on the right there. So it's each of the mailbox servers have redundant copies of each other's databases. And then in the cloud version, the cloud member, we have both of the mail databases are there, but they're both in a passive state. So essentially what you can think of it is you've got each server locally protecting active copies, serving clients with active copies, and then keeping passive copies as well. And then in the cloud, you're just keeping passive copies. And the arrow in the middle there, this is mailbox replication, is referring to the fact that Exchange is going to handle, because of this DAG architecture, it really is as simple as defining where these databases live, what the state that they're in, whether they're active or passive, and Exchange works out the details. So the Exchange services is going to take care of the mailbox replication. It's going to make sure that your messages and your calendar events are all being replicated appropriately across all the members of the database availability group. And it's all handled automatically. So it's not something where you have to get really, really granular. You can actually go with some very basic configurations and get this up and running really quickly. And it makes it really, really simple way to get that sort of resiliency, that I've got this copy of my databases off-site, but I've also got the actives running locally. And it makes failover really simple. To talk a little bit more about the architecture also, I want to point out that in the cloud, so on the N-Skilled cloud side, you would typically have whatever pieces of the puzzle you need for the amount of service you want to provide. So in the simplest example here, I've gone ahead and provisioned, I've said that the N-Skilled cloud will have a CAS server, it will have a hub transport server, and by default in the N-Skilled solution, we always have an AD server that's a member of your Active Directory topology. And so the AD server in the N-Skilled cloud is there for basically giving you the ability to authenticate in the cloud, but also acting as a member of your AD sites and services. So what this does is it defines the N-Skilled subnets in the cloud as a different site in your topology, which is really key to the concept of an Exchange database availability group failover at the site level. In terms of the CAS and the hub transport, if you want to think about it from the standpoint of how would I, in a disaster, how would I get my mail flowing? You would want to have some kind of a server, like for example the hub transport server, already configured ready to receive mail. And if you've got some kind of a solution that you put in front of your mailboxes to protect you from spam or to do some kind of archiving, then in the event of a disaster, you would repoint that solution to the N-Scaled cloud. We would pre-set up a NAT, give you a public IP address, give you the ability to do mail transport to that server all in advance. This makes the cutover really simple. And likewise with the CAS server, you're going to want to provide your clients with access through OWA and through their iPhone and things like that. So we would want to do another NAT there. And in the minimal state, you'd want to have at least one CAS server. You might want to have more than one CAS server. You might even want to have a load balancer. We can accommodate all of those things. We can also accommodate, for example, if you had an anti-spam virtual appliance and you wanted to have a virtual appliance running in the N-Scaled cloud ready to go. The point is that based on your business objectives on the N-Scaled cloud side, let's build out everything that you need to drive your mail infrastructure. When we ask most of our clients and even our prospects, what's the most important data that you have, they always say email. I've never had a client say, oh, I can go a day without email. It's more like I can't go more than 5 minutes without email, or I need email to be up as much as possible. And so based on your business objectives, we can certainly help you develop the solution of putting the right pieces in the cloud and making sure that you've got everything you need to hit your business objectives and give you this site failover capability through Microsoft Exchange 2010 database availability groups. Oops, jumped too many slides. The scrolling is a little bit out of whack here. Okay. So let's cover the scenario then where we have a single server failure. So locally, one of the servers has failed. And it's a mailbox server. It's gone through some kind of a physical failure. What would happen in that case then is that you would already have an automatic, it's basically like an auto-provisioning process that would say, this server failed, take the passive mailboxes on the second mailbox server and make them active. And the rest of your Exchange pieces, your CAS server, your hub transport server, are going to respond accordingly as well. So you might have a little blip, for example, where someone with an open session to the CAS server loses the connection for a minute while the session is reestablished with a new server. It's not session aware, so Exchange isn't session aware. It's not going to be able to just carry that session over, but there'll be just a little blip while it flips over, and you can basically see that even though I've had one server fail and it's now fallen out of the DAG because it's failed, the other two DAG members are able to stay active. So the local server, in this case for performance reasons, since it's on the local LAN, it's going to give the best service to my users. That one's going to be the one that's going to present the active mailboxes. But the cool thing is that no matter what the clients are doing, so all the messages they're getting, all the calendar appointments they're creating, all the rooms they're reserving, all of that information is getting captured in the active databases and continually replicated again to the cloud. So even though I've had a local failure, it didn't affect cloud replication at all. I'm still getting all of this data copied to the cloud in real time. I'm still getting that site resiliency, which is just so key to having high availability in this kind of a service. Oh, and just as kind of a side note, if I wanted to, for some reason, let's say that I had a reason that I wanted to fail over to the active mailboxes to the cloud, that could also be architected as well. You could develop a solution where I'm going to fail the active mailbox over to the cloud instead of to the local server if you had some business reason to do that. Maybe you have some geographic distribution where that makes the most sense. Now in this scenario you see that we've lost both of the servers at the local data center. So both servers have failed. Obviously that's, maybe the whole site failed. Maybe just the blade chassis had a problem and both of the servers are down. Either way, at this point we're going to have to activate the cloud server. And this could be done fairly automatically, but actually as a precaution, because these are separate sites, it's actually better to do it as a manual process. And thankfully the manual process is really quite simple, which we'll cover in a few slides here. But essentially, because both sites are down, let's say that the only thing that failed was Exchange. I've still got my entire network topology up and running. So for the first scenario, only the Exchange servers failed. My network is still up. My tunnel to N-Scaled is still up, or my MPLS connection to N-Scaled is still up. But I'm running off of my mailbox servers in the cloud. Okay? Then in that case, nothing really changes because the N-Scaled environment is a part of your AD topology. We're using a VPN tunnel or an MPLS connection. We're just like another site in your network. And so essentially your mail gets routed through those clients instead. And you could have a situation where For example, if you were natting your email traffic into your hub transport server locally and the hub transport server didn't fail, then it's going to know that I've got to go to the, based on the Active Directory, the updates that happen when you fail over to the other site, it's going to know that I have to go there to deliver mail. I'm going to deliver my mail to the cloud instead. Let's say that instead the whole site fails, so you don't have cache, you don't have hub transport, and your data center is down. Well, in this case then, like I talked about in the earlier slide, we would have pre-architected your natting and everything else to make sure that those cloud servers, the CAS server and the hub transport server in the cloud, are ready to receive mail. They're ready to receive client connections. And so in that case, it's just a matter of changing whatever you need to change, whether it's maybe you've got an MX record that's dropped, it's the lowest priority and it's just standing by waiting to deliver mail to that hub transport server in the cloud. If you're taking your mail directly to your hub transport server, maybe you're delivering it to a virtual appliance that you've got running in the cloud, and you're going to just have the anti-spam appliance in the Nscale cloud taking care of it. Or maybe you're going to go through message one or somebody like that first, and you just need to change an IP address with them to tell them to go to a different one or have a priority set with those IP addresses. The bottom line is that regardless of what failed at your site, properly designed, this architecture gives you high availability for a site failover. That you could have a very quick, around 20 minutes to fail over an architecture like this, quick failover to the cloud with all of your email being delivered and everything ready to go, and all within the skill set of an Exchange administrator. So what does the failover and fillback process look like? In other words, how does it work? What are the steps that I'm going to go through to make this happen? So on the failover side, the first thing you're going to do is you're going to update whatever you need to do for Exchange transport, or mail transport rather. Anything that you need to do for OWA access or client access. So if you've got an A record on the outside that handles all of your iPhone traffic to your Exchange environment, and you need to change that, you're going to want to keep the TTL low on that A record just to make sure that the change will reflect pretty quickly. You're going to need to change those type of IP addresses in terms of the Internet's view of you. So they were sending mail to this site, now they're going to send mail to another site. You would update Active Directory at all the data centers and mark the DAG as stopped in the failed site. This is actually really easy to do. It's a PowerShell command. You would stop this cluster service in all nodes at the failed site. Obviously, if the failure is really severe, that's going to take care of itself. So if the servers have died, the cluster service is going to be stopped by nature of the servers being down. You would update Active Directory at all the data centers and mark the DAG as active in the cloud on the Nscaled side. And you'd ensure that the passive copies of the databases hosted by the servers in the cloud are mounted and activated. So basically, once you've failed over, part of the failover process is that the Cloud Exchange server is going to mount the mail databases, and it'll show. I mean, it just shows like, okay, I was able to do that. They're mounted and they're ready to go. And then you just have the client start connecting. So obviously, there's no session awareness across CAS servers in an Exchange architecture, so it's not like your local CAS servers are in a state where they can just hand a session off to a cloud CAS server. So in that case, what you would end up doing is they would lose their sessions momentarily, but once you've redirected all the necessary DNS, then they would start going to the correct location. That goes for in multi-site topology as well. If you've got a case where you're changing your DNS records to make sure that they're using the CAS server in the cloud instead of the CAS server that's normally in your data center. So after you've failed over, now you've been running on the cloud and you've decided, okay, we figured out what was going on, we figured out what the failure was, now we need to fail back. The first thing you're going to do is restart the database availability group at the primary site, the original site that it was running at, and wait for Dagger replication to update the mailboxes. So essentially replication is going the other way now. The active mailboxes the databases they're on the cloud side, and the passive ones are on the local data center side, and you're going to wait for those mailboxes to update and replicate. From there, you dismount the databases so that you can free the client connections. So in other words, the clients have been connecting to the cloud data center for service, and you need them to stop doing that and connect back through your infrastructure. So you're going to go through and do the exact opposite of what you did before. You're going to disconnect the clients, leading up to the next step. You're going to update the DNS records back to where they were. Anything that needs to point mail back to the original environment, you're just going to essentially undo any of the steps that you did before. and then you just verify client connectivity as the last step. So make sure the clients can connect, that their iPhones can connect, that the BlackBerry server can connect. So from here, how does the solution scale? How do you go up? Because as you may recall, I mentioned earlier that a DAG can consist of 16 servers. So there can be 16 member servers in a DAG. But if you're a really large environment, you might have 16. Even if you were to just go with a single Exchange server at every site, you might have 16 Exchange servers right there. And the reality is that you wouldn't want to think of it that way. You want to think of it as more like a database availability group covers a set of resources like a site. So if you had, for example, 16 sites and you know that the maximum number of DAG members that you can have is 16, you probably don't want to architect a solution where you're saying all of our sites are going to cross-replicate, it's going to be one big DAG and everybody's mailbox is going to be everywhere else. That's really not all that practical when you think about it, because essentially you've got all this replication, you'd have to size the solution accordingly. It would be really difficult to size the solution that way at every site. It would be expensive. The bigger you are, the more expensive that's going to be. And so essentially the way that you would build this then is you would say, and I've used colors to indicate this. So for example, the customer data center in Honolulu, it's a really small site. They've got an AD server. They've got one Exchange server there. And you can see that on the Nscaled Cloud side, the orange box there indicates that there's a DAG member server, so there's a DAG with 2 member servers, one in Honolulu and one in the Nscaled Cloud, and that's one DAG. And then the next DAG is the Chicago DAG, and the Chicago DAG has active and passive databases locally in Chicago and one cloud server that's a member of that database availability group. Same thing going for Boston in this example, that the green, that it's got 2 DAG member servers locally and 1 DAG member in the cloud. And in San Francisco, just for the sake of argument, I decided to for this drawing, make it so that the purple has 2 DAG members locally and 2 DAG members in the cloud. And you might want to do this for, say, performance reasons, for example. You might say, okay, for performance reasons, I want to have my San Francisco users, there's a lot of them, cloud, and so you might want to have 2 DAG member servers in the cloud and 2 DAG member servers locally at the site. So that's one way that you can build a bigger architecture with this design. Having slide issues here. And that concludes the presentation portion of this. So at this point, we'll be taking questions from the audience. Oh, you can go ahead and type your questions into the chat window or raise your hand. Let's give just a few more minutes for questions. I haven't seen any questions come in yet.
Okay, well, if we don't have any questions, I guess that wraps up this week's webinar. And again, if you have a question later on, you can email me. My email address is Sarah, S-A-R-A-H .grant, G-R-A-N-T, @nscaled.com. And I'll send you all a follow-up email so you can just reply to that email with your questions. Okay, Thanks so much for attending the webinar, and thank you, Mike, for presenting. That was great.
My pleasure. Thank you.